about linear systems. Where am I? Here we go. General idea is we've got these two methods, substitution and elimination, that we use to take two equations in two unknowns and find a solution that satisfies both of them at the same time. So for example, here, 6x minus y equals 5 and x minus y equals 0. The big curly brace means they go together, so we're talking about sort of the same x and y. On their own, those are each equations of lines. So if we graph them, those are both straight lines, linear functions. Solving the system means looking for any points that they have in common, right? If x is 1 and y is 1, then both of these things are true at the same time, and that's the only time that happens, right? Any other combination of x, y that's on one equation is not a solution to the other. So the basic idea is you've got these two equations and two unknowns. We mush them together either by substitution, which means figure out how to write one thing in terms of the other thing, and then use that in the other equations. Like looking at this, I took equation 2, solved it for x, and then used that in equation 1 by substituting. So I replaced x with y because this told me that x and y are the same. Then we get a thing that's just in terms of y that we can solve, and then we plug that back in and figure out what x would be to pair with it. That's how substitution works. Elimination, you take the two equations and you combine them by just adding or subtracting them together, possibly more than once. So here we took that first equation, the top line, multiplied everything by 2 because we wanted to eliminate x, so we get those to match. Really, that's the same thing as like subtracting that equation twice. This is easier to keep track of, though. So we scale the whole thing by 2. Then we subtract. X's go away, right? Because 2x minus 2x is 0. We combine everything else, and then we get down to the point that we have a value for y. Once we have a value for one of the things, plug it back in somewhere to find the other thing, right? And I guess I've erased part of this. The solution here was the point. Oh, what is that? Add 3, or add 4, sorry. So x is 3. We did all this last week anyway, so solution would be 30 negative 2 then, right? The x that goes with the y. And again, the idea is that these are intersections of these things graphically. Since they're straight lines, if I take two straight lines, they can only intersect one time. And then we had these two, kind of edge case things where you've got parallel lines that don't intersect at all, or the same line, and you get infinitely many solutions. Today, we're going to take that same idea and talk about nonlinear equations. So for example, this, x minus y equals 3, that's a line. Again, x to the first, y to the first. So this is a line. X squared plus y squared equals 9, though. That's a circle. So we're talking about intersections between a line and a circle. Here's what this one looks like. X minus y equals 3, and x squared plus y squared equals 9. Talking about intersections of nonlinear things or systems of nonlinear equations, there are different and more options for what can happen then in terms of the number of intersections they have, right? Straight lines, you either cross once or you don't, and that's pretty much it, right? A circle and a line, though, well, this one crosses twice, so this is going to have two solutions then, right? But I can imagine how a line could maybe miss entirely and not have any, right? It could go through the middle of the circle like that and have two. It could even sit tangent to the circle, just kind of brush up against it and just have like one solution, right? So we're not always going to have as much maybe like insight or intuition about how things are going to go beforehand here, right? Because the things are more complicated themselves. We'll see some stuff that we're even less familiar with. The point is that the options open up a little bit. The methods that we use don't change, though. So if I'm looking at this, x minus y equals 3 and x squared plus y squared equals 9, and thinking again in terms of using either substitution or elimination to solve, what do you see? Okay, let's think about that for a second. Let's chase that for a minute. If we take that and square it, what you're actually squaring is that, right? You're allowed to square both sides. You don't get to square individual pieces. You can square both sides though. But if you actually square this, right, meaning take two of them and multiply them together and expand, you get x squared minus xy plus y squared, right? Think about, doing like a FOIL expansion on that. So yeah, we have an x squared and a y squared, but we also get this sort of mixed xy term, right? That's going to be a problem. If you think about, combining these, this has an x squared and a y squared, but at some point, even if I try to do an elimination type thing, this isn't going to go anywhere, and that's going to leave me with an equation that still has both x and y in it, right? And the whole point of the elimination is to, well, it's in the name, right? To eliminate one of the things. So squaring it like that is probably not going to help us then because, again, this thing's going to be sort of in the way. Typically, that'll happen anytime you try to like change the power on something, right? Whether it's by squaring or multiplying in another variable or dividing something out, like any version of that is probably going to make things a little bit worse, right? Rather than better. So what that means for us in practical terms is that if we don't have like terms, like there, right? X and x squared, those are not like terms, right? You wouldn't combine those if they were all, in line and you were combining like. So those are not like terms. These aren't either. What we take away from that is we can't use elimination. Because any version of trying to change those so that they are like terms is going to introduce some kind of weird thing like what we just talked about that's going to be a problem, down the road, even if we're able to eliminate the thing we wanted to eliminate. So looking at, some of these other examples here and kind of thinking about that, here all the x terms are squared, right? Well, I can eliminate those then because they're the same kind of thing. All the y terms are squared. I can eliminate those because they're the same kind of thing. Or I could solve for one of these and use it to substitute into the other one, right? Substitution just means replacing like for like. You don't have to solve all the way down to x. You can solve for x squared and then replace an x squared with that. Like that works. So we just have to kind of stretch our idea of how substitution and elimination work a little bit. Here, though, again, I wouldn't combine x and x squared. I wouldn't combine y and y squared. So elimination is kind of out then, which means that we're looking at something where we need to try to set up a substitution. The way substitution works is you solve for something and replace for that same thing in the other equation. So pick something here that you would like to solve for. Okay, take the first equation. You want to solve for x or for y? Doesn't matter. Okay, doesn't matter. We just have to pick one, right? Let's solve for y. X minus y is 3. So negative y is 3 minus x. So y is negative 3 plus x. And the way the substitution works is we replace like for like. So the first equation tells me that, hey, you can write y as negative 3 plus x if you want, or x minus 3 if you prefer that. That's the same thing. You can write y like this if you want. Then I go back and look at the other piece of information I have, the other equation, and see, okay, well, if I think about y like this, what does this tell me about x then? So x squared plus, in place of y, negative 3 plus x, still got a square on it, equals 9. That's our substitution. Is everybody okay with what just happened? Yeah, okay. That's kind of the key thing, right? Now, at this point, after we've made our substitution, we should have an equation that only has one variable in it. Okay, this only has x's, that's good. And that we know how to solve. What kind of equation is this? Quadratic, oh my goodness gracious. Do we know how to solve those?
Yes.
Thank you. A little more enthusiasm from the rest of y'all. How do you go about doing it? Expand this thing. So negative 3 plus x times itself, or again, that's x minus 3 if you want to rearrange those. Expand, that's 9 minus 3x plus x squared. Again, it's quadratic, so now we're just collecting terms, right? Quadratics, you get everything together onto one side of the equation. So I'm going to combine like terms. I'm also going to move that 9 over. We've got 2x squared minus 6x is equal to 0. Okay, so there's our quadratic in standard form. Everything on one side of the equation is equal to 0. What do you want to do? X squared plus x squared. You're adding them. There's the same kind of thing, and you're adding, so it's two of them. So 2x squared minus 6x is 0. Did they have any common factors? Two and six are both. 2 and 6 are both. They're both even. Okay, so they have a 2 in common. And x squared and x both have an x. Okay, so let's take out 2x. So 0 and 3. Okay. Now we need to figure out what y is to go with that, right? But we've already done, about half of the work, more than half, really. We've already done most of the work that we need to do that. We've got 2x values, and we've got this little equation that tells me exactly what y is based on x. So if x is 0, then y is negative 3 plus 0, so negative 3. If x is 3, y is negative 3 plus 3, so 0. All right, I'm just using this here to find y based on the x values that we just got. right? You could take those x values and plug back in anywhere that still has an x and a y in it together, right, and get y. But this is the most straightforward place to do it because we've already done the work to sort of rearrange and solve for y. So our solutions then, as ordered pairs, because the points are 0, -3, and 3, 0. All right, when x is 0, y is -3. When x is 3, y is 0. Okay, so differences between linear systems and nonlinear systems. One, sometimes we have to be a little more choosy about how we go into it, right? Linear stuff, like we talked about before the break, you can always do whatever you want. It's just a question of, well, maybe if I make the right choice, I don't have to deal with any fractions, right? Like that's about as complicated as that gets. Other than that, you can always do whatever you want. Nonlinear stuff, because of the like term thing, we don't always have the same freedom. Again, if I start adding these together, none of those things combine, so we don't really get anywhere, right? We don't really make any progress. So instead, we go about a substitution because we can do that here. Sometimes we might have more freedom, we might have more options. Here, we're kind of limited. Once I decided substitution's the way to go, decide what I'm going to solve for. We picked y just because, right? You could solve for x, and I think I did when I worked through this for my solutions that are in Blackboard, that will be in Blackboard soon. I think I did solve for x instead and work through it that way. You get the same thing, right? It doesn't matter. So that part's a little bit different. The other thing that's a little bit different is just that when we get to solving it, a lot of these are going to end up being quadratic because, well, that's a thing that we are comfortable with solving, right? And if you look at the other problems there on the examples, you see a lot of squares show up, right? Doesn't mean it has to be square, but that's a thing that we're comfortable with solving, or hopefully are comfortable with solving at this point. So a lot of them are kind of geared toward that. Okay? And that means then that we can end up with multiple solutions, right? You can still get one, you can still get none. You might get two, you might get four. I don't know. It depends on the things, right? Okay. Does anybody have any questions at this point? Okay. I think a good way to spend a little bit of time would be you trying this one then. It just took me 3 tries to remember which app that has a green icon is the one where I take attendance. Which is fun. So I'm not quite at 100% yet either. So I don't know what date it is. Yes. Because they're like terms and because they're like identical, right? It's 1x squared and 1x squared. So to get rid of them, what you're doing is subtracting them. Okay? Which means you subtract everything else. So you'd have negative y minus y squared equals negative 1 minus 5. Okay?
Right.
And then you go from there.
Yeah, I plug that back into just both.
Either one.
Okay.
Yeah. Yeah, I mean, the whole point is that you ought to be able to plug it into both and get the same answer back.
Yeah.
Right? Assuming that, like, we haven't made a mistake somewhere, right? That means you plug into one of them to figure out what you solve for y and you figure out what x would be. Okay? Okay. Anybody have an idea for a first step?
Well, I did substitution,
Okay.
and got y equals 1 plus x squared.
Okay. So you took this. Add y and add 1, and you get y is x squared plus 1. Okay. Ah, okay. I see where this is going. And then what? That's making you a little uncomfortable about it. Okay. So then you take it to the other equation, you plug in, and in place of y, we put x squared plus 1. But in that other equation, y gets squared. And what do we end up with then? Some other stuff and an x to the fourth term, right? Okay. At that point, this isn't wrong, but at that point, I would probably go, whoa, 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 buddy. Like, I'm going to back up and see if I can figure out some other way to go about that, right? Again, it doesn't make it wrong. You can still get there. You still get the correct answer, but we have to solve the fourth degree thing, which may not be all that much fun. So at this point, I would probably bulk, again, like on a final, at most, you're going to be solving one of these things, right? So, you have the time to kind of say like, okay, I'm gonna step back and reevaluate a little bit. Other stuff we might try because we ran into that fourth degree thing, and I'd rather not deal with that.
Elimination.
Okay. These are the same kind of thing. Because they're the same kind of thing, we could eliminate it. Notice we would not be able to eliminate y here because they're not the same kind of thing, right? One of them's a y, the other one's a y squared. Those aren't like terms. They don't combine if we add or subtract them. And again, we can't really like fix that. But we can eliminate the x squared terms. Because I have 1x squared here and 1x squared here, the way to eliminate them would be to subtract. So subtract. X squared minus x squared is 0. Those go away. That was, by design. Elsewhere, we've got negative y minus y squared, which is just negative y minus y squared. They're not like terms. We don't combine them. It's just negative y minus y squared. And then negative 1 minus 5, which is negative 6. At this point, again, we should have something with only one variable. Do we have only one variable or one unknown? Yeah, y. Okay, that's good. And it should be something that we know how to solve and like feel okay about solving, right? Is that something we know how to solve? Yeah, it's quadratic, right? Last time we ran into a thing that was degree 4 and we were a little more hesitant. Like at most, I don't want to solve that. Quadratic though, shouldn't scare us at this point. I'm going to rearrange a little bit. So just add both of these over to the other side. We get y squared plus y minus 6 equals 0.
You do it by just adding 6, because that's what I did. Fine.
You could also do it by just adding 6. I didn't want the negative coefficients, but you can fix that another way too. The point is it's a quadratic, get everything onto one side somehow, right? And then solve that quadratic. Which I'll do privately and allow you a chance to do the same if you haven't already. All right. You get negative 3 and 2. Okay, now what?
You have to plug those in somewhere.
Plug them back in somewhere. Yep. Plug it back in somewhere. It has to be somewhere before we got rid of x, because we need to figure out what x is, right? So it doesn't do me any good to plug these in here, because then I just get a thing that's true, which is good, but like I need what x is. So plug it in somewhere that still has an x in it. And as long as we've done everything else correctly, it shouldn't matter which one we plug into, except that one of them might make our life a little bit easier than the other, right? So if I'm looking here and plugging in y to figure out what x is either of these going to be easier to work with than the other? Yeah, I mean, the first one maybe a little bit. In both cases, you know, you take your y value, you do something to it, either change the sign or square it. Both of them have an x squared, though. That's the main thing I'm looking at. They both have an x squared that we're going to have to deal with later. If one of these was x to the first, I would for sure choose that one because that's a little bit, you know, less stuff to deal with, right? It shouldn't really matter here, though. So just pick one to plug into. Y is negative 3. Then that first equation becomes x squared minus negative 3 equals negative 1. So x squared plus 3. And if you subtract 3 from both sides, we get that x squared would be negative 4. But if we're looking for real solutions, which we are here because we're talking about intersections of these things, can x squared be negative? No. Okay. So that doesn't go anywhere then. On the other hand, if y is 2, x squared minus 2 equals negative 1. Add 2 to both sides. X squared is 1. And so x is 1 or negative 1, right? Square root of both sides, but we're taking the square root, so we get a plus or minus along with it. X is plus or minus 1. Our solutions then. Well, we got with y being negative 3, we got something that didn't really go anywhere, right? Got that x would have to be a negative. We're talking about real solutions because we want intersections. So we toss that out. When y is 2, we got plus or minus 1. That's 2 points then. One of them, x is 1 and y is 2. The other one, x is negative 1 and y is 2.
Sorry, why is it plus or minus one?
To get rid of the square here, we can take a square root, right? But if we take a square root, a plus or minus comes along with it because 1 squared is 1, but negative squared is also 1. Sorry, negative 1 squared is also 1. And again, you can check if you want to, right? 1, 2, plug into either of those, and they're both true. Negative 1, 2, same thing. You don't need to do that. Kind of everything that can happen has sort of already revealed itself. Okay. Do you have any questions about anything? All right. Well, let's take the time that we have left, about 10 minutes. For each of these, think through the first couple of steps, right? Like try to get to this point. So the point where you've taken the two equations and combined them into a single equation with only one unknown in it. So, by substituting or by eliminating, try to get through that part for these 4 that we have left. Mm-hmm.
After this point. I do the same thing that I did over there. So you make it a zero. I would suppose.
No,
Yeah,
not the
okay,
individual
okay.
pieces, no. So here we can do that because we factored.
Okay, I see.
Then you had like this times this equals 0, which means either one of them or the other is 0.
Yeah.
20 minus 5y squared. That's quadratic in y.
Okay.
So you can look for common factors. You can use quadratic formula. Since there's just a y squared term and no like no y, like linear term, you could just get them on opposite sides of the equation and then take a square root, similar to what we did here. Yeah.
Awesome.
All right, x squared plus y squared is 4, and 2x squared minus 3y squared is negative 12. Just for the sake of looking at a picture, that's it. The first equation is a circle. The second one is a hyperbola. You guys will go on to pre-cal. You'll spend a lot more time with those there. And they intersect at these 2 points, right? They're tangent there. So we should end up with 2 solutions. But how could we go about combining these to solve this? Okay. Multiply that by 2, and you get 2x squared plus 2y squared equals 8. And I assume that we're doing that to try to eliminate that. Okay. So if we multiply by 2, we get the x squared terms to line up, which means we can subtract and eliminate that. If you do that, you get 2 minus negative 3, so add 5y squared, and 8 minus negative 12, so again, add, equals 20. And if you did substitution or something else, you should also end up with 5y squared equals 20. Or if you did the elimination the other way, you got something involving x squared, right? Okay. Then to solve from there, I'll like shortcut this part a little bit so we can talk about kind of the strategy on some of these others. But this would mean that y squared has to be 4, so y is either plus or minus 2. And then again, you plug that back in somewhere and then find x squared. I would probably go with the first equation because there's a little bit less going on, but again, you plug it back in somewhere and get the x values that go with it, right? Okay. Thoughts about this one? Can we eliminate x? No. Can we eliminate y? No. So we got to do some kind of substitution, right? Solve for, I mean, I'd probably go for this, right? Of all the 1, 2, 3, 4 things I could choose to solve for, this one should be the most straightforward, right? X minus 3y is negative 5. That means x is add 3y to both sides, 3y minus 5. And then the other equation becomes 3y minus 5 squared plus y squared equals 25. Our like progress check is one equation that has taken information from both of them that we started with and has only one variable in it, right? And again, is hopefully something that we know how to solve. So there you go. There's that. Solve for y. It's quadratic. Here. This is a place where you look at it and it looks different, right? And I can see it on some faces. When things look different, we start to panic, right? But what are you to do first? Not panic. I've done some of the work for you here, right? What's y in terms of x? Negative x squared plus 2. Hey, I did the substitution part for you, right? Or I set it up for you anyway. Take this and put it right there, and you're good to go. Or y and negative y, if you add those together, you eliminate y, right? So it looks different. Things are rearranged a little bit differently, but in such a way that actually some of the work's done for us. As long as we don't panic. So this says that x plus x squared minus 2 is 0, or x squared plus x minus 2 is 0, and then you solve that quadratic. The last one, x plus y squared equals 4, and x squared plus y squared equals 16. We can eliminate y squared. We cannot eliminate the x terms. We could do a substitution for x, or we can eliminate y squared. If I see y squared and y squared, same coefficient, like lined up just, nicely like that, that's probably how I would go about this. Subtract those, you get x minus x squared equals negative 12, and then you go from there. Okay? Pretty much all of these involve solving a quadratic, so you're going to get a lot of practice with that, which is good. It's timely. We haven't had to solve a whole lot of quadratics in a while, so you get some practice with that here. All right, so finish that up. I would go ahead and try to get some homework knocked out as well, and then again be kind of looking back at old stuff and sort of be gearing up for the final. I will see you all tomorrow if I can help with anything in the meantime.